Hello, we are going to start chapter 2 now. Chapter 2 is all about matrices and the system of linear equations. So I'm going to give you some basic idea what we are going to do in this chapter. So linear system of equations look like we have several equations with several unknowns, look like this kind of form. So it's like 2x1 minus x2 plus 5x3 equals 1. 4x1 plus 2x2 minus 6x3 equals 3 minus x3 equals 4. So here you can see we have three equations and three unknowns, and there's no power, and this is a linear. They are all linear equations, so we call those our linear system of equations. And we're going to introduce matrices. So by using matrices, we can solve this equation system easily. So the matrix, if we pick all the coefficient out, so kind of like this thing. So that's the coefficient matrix. Okay. Something like this. And we call that matrix. We will learn this in 2.1 for the definition. And so here just a basic introduction, and in chapter 7 we are going to solve linear system for differential equation. So we are going to solve, so here we solve linear system of equations. In the future we will solve system of linear differential equation. Okay, this class is called the differential equation. So our goal, we just want to use some tool to solve linear differential equation. That's the final goal. Now let's take a look at 2.1. 2.1 is called the matrices definition and the notation. Okay, notation. So in this section, we are going to learn a lot of definitions. I think from 8 to 9 definitions, but it's pretty easy, just introductions. So the first definition is called the matrix, definition 1. Okay, and here that is m by n. Okay, we call that m by n. Matrix is a rectangular array of numbers. Okay, yes, a rectangular array of numbers. So we have arranged in m horizontal rows and n vertical columns. So row means horizontal, and n vertical columns. Okay, and the entries are called the elements of the matrix. So this is the definition for the matrix, and all the entries are called elements, okay, of the matrix. And the m by n is called the size of the matrix. Some matrix can be big, some like a 2 by 2, 3 by 3, so that means the size of matrix. Okay, and sometimes it's also called the dimension. Same thing. So here I'm going to give you one example of the matrix. Let's take a look. Usually for the matrix we use the capital letters, okay, A, B, C, capital, to express matrix. Okay, so we put a big bracket here, and we put, like here we have 2 rows. Okay, and the second row is 0, 5, 7. So you can see here we have 2 horizontal rows, 3 vertical columns, right? And in this matrix, we say that is 2 by 3. Row by column is always, okay? This is the 2 by 3 is the size of the matrix. M means number of the rows. And N means number of the columns. Let's take a look at another matrix. Okay, and please tell what's the size for this matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's take a look. So here we can see we have 3 rows, 3 columns. So the size of matrix is 3 by 3. Right? Okay. And in general, there is a general definition. The matrix is given by this way. So here it's going to be M by N. Okay? And the first number in the first row and the first column, we say A11. Okay. And the second number, the first row in the second column, we say A12. And same thing, A13. Okay. And here, you can skip. And the last number in the first row, so for the row, we used 1, okay? And the last number, because we have n columns, so A1n. Second row, A21. Second row, second column, A22, A23, and A2n. And we can skip the middle rows. And how many rows do we have? We have m rows. So here M1, AM2, AM3, and the last number is AMN. Okay, that's the general definition for the matrix. And sometimes we also write down that is like AIJ. Okay, AIJ. Let's take a look at example. If so here, let's take a look at this matrix. 1, 2, 3, 4. Let's write down the entries or elements. So A11 equals what? A12 equals what? And A22, A21. Let's take a look. A11 means the first number, first row, which is number 1. A12 is the first row, second column, which is number 2. A22 is, okay, second row, second column, 4. A21, second row, first column, which is number 3. Something like that, right? Let's see. If we can try this one, because this is pretty easy, so we don't do the official example. So write the matrix with given elements. And those are given by A11, which is 1, A21, which is -1, A12 is 5, A22 is 3. Okay, so you can see here we have 4 elements. Actually, this is 2 by 2 matrix. Let's write down the matrix 2 by 2. A11, 1. A21, where do we put this number? A21, second row, so first column, 91. A12, first row, second column, 5. A22, 3. Something like this. Pretty easy, right? Okay. Let's see, definition 2. Definition 2, 2 matrices A and B are equal if all the elements are the same, and also they have the same, those two matrices have the same size. So two matrices A and B are equal. That means they have to be exactly the same thing. In that case, we write A equals B if two conditions. They have the same size. M by N, okay, same size. Second, Aij, that means the elements in matrix A equals Bij. All corresponding elements are equal. That means all corresponding elements are equal. Okay, pretty easy to understand. Equal means they have to be exactly the same thing. We can take a look at just two matrices. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 0. So you can see they both 2 by 3, 2 by 3. They have the same size, but the last number are different, right? So they are not equal. A23 is different from B23, so doesn't equal to each other. Next definition. Let's see. We have 1 by n matrix. Think about 1 by n look like what? What the 1 by n matrix look like? It's called a row n vector. Okay, and a n by 1 matrix is called a column vector. Row vector and column vector. Okay, column and vector. Doesn't matter, you can just say column vector. And the elements of a row or vector are called exponents of the vector. The elements of a row or column vector are called the components of the vector. Let's take a look at one example. So here we can say, okay, we can say example 1. Let's take a look at this matrix. 1, 3, 5, -1. Look at the size. What is the size for this vector? Matrix. How many rows do we have? So we have 4, right? So 4 rows, 1 column, so 4 by 1 matrix, and we can look, this is like a vertical, so this is just like column. So in this case, we say that is column 4 vector. Column vector, so we call that column vector, right? Column vector. So how to tell is you don't need to memorize the definition. If it look like a column, that's column vector. If it look like a row vector, it's called a row vector. So look at this vector B, 1/2, -2/5, 3, 7. Okay, so this is 1 by 3, right? So this is actually row 3 vector. Okay, so in Cat 3 we learned that vector in R3 is like, okay, vector, so we write down 1, 2, 3 like this vector, right? V vector equals that. So we call this is a vector. So right now we do the general thing. We have row vector or column vector, just depends on how we write the vector. And all the elements are called components. Okay, components. So let's see. Let's try one exercise problem. Write a column 5 vector, okay, and also write another one row 4 vector. So please try those two. You can do any number. You can put any number for the components. So let's see. Solution, column 5 vector. So you can just do column 1, 2, 3, 4, 5. How about that? Right, 5 of them. And the row vector, and it says 4 components. So you can just do 1, 2, 3, 4. 1, 2, 3, 4. So this is a row vector. Okay. Now let's take a look at a matrix. This matrix is 4 by 3 matrix. So let's see. 1, 2, 3, 4, 5, 7, 8, 9, 9. You can put any number here if you like. So we can see this is 4 by 3 matrix, right? In this case, we can look this as matrix is made by 1, 2, 3, 4, made by 4 row vectors. Or we can look at this made by 3 column vectors. Can you see? Okay. So the row vectors, let's try to write down the 3 column vectors. The 3 column vectors are column 1 for the first column, second column 2, 5, 9. So we look vertical way, right? And 3, 7, 9, 12. Okay, column vectors. Let's try this one exercise. Write the row vectors of the matrix. The row vectors of this matrix. Okay, please check. So this matrix has 3 row vectors, right? Those 3 row vectors are 1, negative 1, 3, 5, 6, 7. Okay, those are the 3 row vectors. So let's see. We have another definition kind of thing. Let's take a look at this. If A1, A2, AN, they are column vectors, M vectors, then okay, they are column vector. So think about the column vector, they look vertical way, right? So they are not a number. So A1, A2, AN, they are not vector number, they are vectors. So they may include several numbers in them. So in the book they write bold, but if you want you can put arrow there, doesn't matter too much, but no. So just think them as vertical. And now we put them together like A1, A2, and AN. So think about like what does A1 look like? is kind of like array of numbers vertical way. So let's give us a matrix, right? So let's denote the m by n matrix because we have m rows because they are the m vectors, and how many columns? N columns. So that's why m by n vectors. Same thing if we have b1, b2, bm are row vectors. So we can write the matrix as row vectors, so they are in horizontal way, so we can write down b1 because b1 is like this way, b2, right, and bm. Okay, so same thing, this is m by n, row and vector, doesn't matter. Okay, so just keep in mind, sometimes for the matrix we can look them as a matrix made by row vectors and all column vectors. So let's take a look at this one. We can say this example. Example 2. If A1 equals to 5, 1, 2, A2 equals 1, 6, 7, A3 equals to -1, 2, 4. So let's see those A1, A2, A3, they are all column vectors. If we put them together like A1, A2, A3, okay, so we can get a matrix 5, 1, 2, first column, 1, 6, 7, and -1, 2, 4. Something like that. Okay, pretty easy to understand, right? We can skip the exercise, pretty easy. The next definition is pretty important. Okay, definition 4. Yeah. It's called the transpose of a matrix because in the future we're going to use this. If we interchange the row vector and the column vectors in a matrix, and the column vectors in a m by n matrix, then we can get a n by n matrix called the transpose. Okay. N by m, switch the order of the row and the column n by m matrix, called the transpose of matrix A, and denote by this one. Denote by this A T, put a capital T at the right corner, so that means transpose. I'm going to show you what's the meaning of that one. Okay, what's the meaning? So for example, if we have matrix, we start from the easy one. 1, 2, 3, 4. Let's see. Okay, so this is 2 by 2, right? 2 by 2, and we have, this is the row column, row vector. So this has 2 row vectors. Now we change the row vector, the first row into first column. So it's like 1, 2 becomes here. And 3, 4, interchange row vector and column vector. So this is the transpose of the matrix A. First row become the first column. Can you see? Second row become the second column. Let's try the example. So we are going to do a general. This is 2 by 4 matrix. 1, 2, 6, 2. 0, 3, 4, 7. This is 2 by 4 matrix. We're going to find the transpose. So the transpose of this matrix becomes what? First row become first column. So become 1, 2, 6, 2. Right? First row, look at first row, become first column. Second row become the second column. And you can see this is 4 by 2. The size n by n switched. Okay. Let's try this exercise problem. If the matrix equals 1, 3, 5, 2, 0, 7, please find the transpose of this matrix. Okay. Here's the solution. The first row becomes the first column, 1, 3, 5. Second row, 2, 0, 7. And the third row, 3, 4, 9. Okay, 3, 4, 9. Let's see, definition 5 is called a square matrix. So we are going to do a lot of definitions in this section. Square matrix, you can see, think about from the name, it's like a n by n square. That means 2 by 2, 3 by 3, 4 by 4. So the column and the row, the number of the column and the rows are the same. Okay, so like n by n matrix is called a square matrix. Square matrix. Okay, and the elements, let's see. The elements AII, that means what? AII means is called the main diagonal or leading diagonal element. Make up the main, because they are in the diagonal position, like A22, A33, or leading diagonal. Main diagonal or leading diagonal. So look at the matrix. So it becomes A11, A22, A1n, and it's n by n matrix. So last number is n by n, right? And A21, A22, A2n. The last row becomes AN1, AN2. Okay. So if we look at AII, those means those numbers. Okay. Actually, let's give us diagonal. If they are all in the diagonal position, they are called the main diagonal. And there's another definition. The sum of the main diagonal elements is called the trace of the matrix A. So let's see. The sum, if we add all those diagonal elements together, the sum of main diagonal elements of the n by n matrix is called the trace. Of A, okay, and is denoted by TR matrix A, okay, parenthesis A. So what's the meaning of the trace A? Trace A means we add all the main diagonal elements A and N. For example, if we have just 1, 2, 3, 3, 4, 5, 6, 0, 9, something like this. And it has to be square matrix. Okay, square matrix. Let's see. So what's the numbers in the main diagonal? So we just add those together, right? So if this is A, so the trace of this A equals 1 plus 4 plus 9, so which is, okay, 14. Pretty easy, right? Just definition. Definition 6. Lower triangular. So let's see. Definition 6. N by N matrix is assigned to be lower triangular if Aij equals 0 for I less than j. So I'm going to show you an example. Don't worry too much. It's pretty easy to understand. And the same thing, upper triangular if Aij equals 0 for I greater than j. Okay, so let's take a look at the example. You don't need to memorize the formula. If you don't want to look at the formula, that's okay. I'm going to show you just the meaning, showing the example. So here, let's see. We have a matrix 0, 2, 6, 0, 0, 3. Look at this one. So you can see it's like for the lower part of this triangular, okay, it's like a triangle, right? Like triangle, and we have all zeros here. So in this case, we say that it's upper triangular. Okay. Same thing, if we have numbers, so for the upper, if they are not zero, so we say upper triangular. So let's take a look at this one. 0, 0, 0. Okay, in this case, we say, okay, you can see they are not non-zero, so we say them are lower triangular. Definition. So let's see. If a matrix look like this, it's called the diagonal matrix. I'm just going to give you the example. Okay, diagonal matrix means what? Diagonal matrix means something like this. It only has number in the diagonal position, and all the other numbers, elements, they are all 0. So it's like, this is 3 by 3. So you can see only in the diagonal position, we have number. So it's called the diagonal matrix. Okay, diagonal matrix. And let's a quick review. What's the trace for this one? 1 plus 2 plus 3 should be 6, right? Trace. And in this case, for the diagonal matrix, sometimes we just write down this way, DIAG, like D1, D2, and Dn. So that means diagonal matrix is only given by diagonal elements. Right? So here Di, they are diagonal elements. It's like an AII. Okay, diagonal elements. Let's see. Example. If this D is given by this one, 1, 2, 0, 3. Okay, let's write down the D. Write out the D matrix. Diagonal matrix has to be n by n. So we can just write down this. So you can see we just write down 1, 2, 3, 4 in the diagonal position, and we can see this is 4 by 4 because we have 4 numbers here, 4 by 4, and we just fill zeros to the other position. So you can see 0, 0, 0, 0, 0. Okay, so this is a diagonal matrix. You can write down a 2 by 2, so you can write down like a DIAJ. Let's see. Let's write down this matrix, which is 2, -1. Try. So D equals what? This is 2 by 2, 2, -1, and 0, zeros. Right? Pretty easy. Symmetric matrix. Okay, let's see. Definition 7. Symmetric matrix means I can give a example. So it's like 1, 2, 2, 4. Okay, all like 0, 5. So this symmetric means they have to be kind of symmetric. Those numbers are the same thing. Same thing. The definition, the official definition is given by this one. It has to be a square matrix. A is called asymmetric. If the transpose equals to itself. Okay, transpose equals to self. Symmetric. I can show you an example. So you can see if we like change the first row in the first column, so same thing, right? 2 and 2, same thing. And we can look at another one. So 1, 2, 3, symmetric. So it's like -1, -1 here, and this 3, 3 here, 0, 0 here. It's symmetric. And this is symmetric matrix. And if you look at this transpose, so transpose equals what? First row becomes first column, 1, -1, 3. Second row becomes second column. Third row becomes third column. So you can see they are exactly the same thing. Here I'm going to write a matrix, and you can see if this is symmetric or not. Okay, please tell. This is 3 by 3. Is this symmetric? Let's see, okay. This number equals that one, okay. 4 equals 4, 5 equals 5. So yes, this is symmetric actually. Okay. And the last definition in this section is called the matrix function. So definition A. Matrix function. That means the elements can be function. So let's see. Just means the elements are functions. For example, let's take a look at this matrix. So the first element is a function 5t plus 1 and 3t, 2t, t squared minus 1. Okay, this is 2 by 2 matrix function, right? And let's take a look at this one. This is t squared t cubed e to the 3t. This is a column matrix, column vector, and it is a matrix function. And in the future, in the next section, we are going to do the algebra of matrix. So we will have derivative and integration of a matrix function. So it's pretty easy. So we will learn that in the next section. We can stop here. That's everything we need to know. And I'm going to give you a summary of all the definition here below the notes, and then you can review those definitions.